when we look at the night sky, we see beauty, but scientists like Professor Martin Barstow see questions waiting to be answered. So, for over 3 decades, he's helped build and guide some of the most powerful space observatories ever launched, and now he is helping prepare for the next one, the Habitable Worlds Observatory, HWO, a mission that could finally tell us whether we are alone in the universe. So let's meet the man behind that mission and explore how the UK and the world are getting ready for humanity's next great space telescope. So this is the second of 3 episodes talking with Professor Martin Barstow. It's an honor to have you here. So welcome back. Today we talk about Habitable World Observatories, its science and the vision behind it. So we'll start with the great questions. Well, one of the most ambitious one among humans, which is, are we alone in the universe? A lot of people are waiting for one of those famous questions that everyone asks more or less in their life, and I'm talking about the are we alone question, because
Okay.
as
Yeah,
yeah.
it's a really important question. I think it's also interesting. I think when you get to my age, you can have quite an interesting perspective on it because when I started out in my career,
Mhm.
you know, that question wasn't a scientific question, really, very, very straight.
Okay.
I grew up as a young child seeing Apollo fly and first landings on the moon. But also at the same time, there was all this science fiction stuff, Star Trek,
Mhm.
everybody's, I'm sure, is familiar with. But
Yeah,
the,
I'm a big fan of Star
but
Trek.
the origins, the first Star Trek series,
Yeah.
and big blockbuster films like 2001 Space Odyssey,
Mm.
and other things. And so there was an idea in people says, yeah, there might be life out in the universe, but there was no data.
Mm.
Uh, you couldn't ask that as a scientific question because the technology wasn't there to actually really make substantial inroads into that. There'd been a bit of work done searching for radio signals, but nobody knew if there were any other planets orbiting other stars. Uh, the only planets we knew of were the ones in our own solar system. Uh, but that all changed very quickly in the sort of mid-90s when telescopes started to become sensitive enough and techniques were created to actually detect planets directly or indirectly through motions of stars or through light dips as planets
Mhm.
pass in front of stars. And I think that was you know, that made a big difference because all of a sudden and quite rapidly, these instruments were discovering first a handful of planets, then dozens of planets, and now we're into the thousands of planets. And once you've done that, you can start to ask the question, okay, well, we know the planets are there, but what are they like? And is there life out there? And it becomes, it moves from being a bit of science fiction that we all like to talk about into being a real scientific goal, one that we're actually capable, if we develop the right instrumentation, of answering. So I don't know whether we're alone or not. I find it hard to believe that there isn't life outside in the rest of the universe because it's so vast. There are so many planets. The conditions for life surely must exist in other places.
Mhm.
But then it becomes a matter of chance. What is the chance that life gets going? Can it survive? We live in a pretty perfect place for life. But then again, it would be, wouldn't it? Because we're here. Uh, and we don't know how many planets are really like the Earth and so perfect.
Yeah, but maybe they don't need to be well, let's say 100% like ours.
No, probably not. But there are some things that Earth has that probably any life-bearing planet has to have. Like
Mhm.
it's got to be orbiting a star that doesn't do too many nasty things. It's got to be orbiting a star that's got a pretty long lifetime to allow the time for life to get established and for evolution to happen. Uh, it's got to be orbiting a star or at the distance from a star where the basic ingredients for life that we're familiar with are accessible, like water. It's probably got to have an atmosphere of some kind. I mean, there may be very, yeah, more exotic forms of life that we couldn't even conceive. But if we just think about life a little bit like ours, then there are various parameters. And there are other important things that may be surprising, like the role of the moon
Hmm.
is really, really important in how life became established.
Yeah,
Um,
this is usually an underestimated thing.
yeah,
Not everyone talks about the role of the moon in
yeah,
life.
yeah. I mean, the way life exists on this planet has been driven by the fact that we have a moon, and it goes around us about once a month. Not always that time scale. It has been closer in and orbiting faster
Mhm.
in the past, but the cycle that it introduced, uh, it keeps the planet stable as well in its rotation on its own axis. So it creates stability for life that wouldn't exist if it wasn't there.
Yeah, and I think that when we introduce this, I would say this topic, everyone starts thinking about, as you said, only recently. I mean, in the last maybe couple of decades, something like that, this has become a real scientific question. And with I would say the advent of the Hubble and the Webb, this can be can get some answers in real terms. And also, by looking at the topic of today, which is the Habitable World Observatory, it's usually seen as like the next step of the web. So, but by talking, we know that Hubble and Webb are sort of complementary one with each other. But what's the role of the HWO in this
Yeah.
sense?
So Hubble was never built to look at exoplanets,
Mhm.
but actually has done a lot of science because since their discovery, astronomers are pretty clever people, and they'll always work out a way of trying to extract information, even if they never knew about these objects when the telescope was built. Webb was also first designed before everybody knew about all these planets, but it was still in that design process when they first started being discovered. So there's was more attention paid to how Webb might look at extrasolar planets. The challenge is that neither of these telescopes has the capability really of looking for planets like the Earth. So they do a really good job on giant planets like Jupiter and Saturn,
Mhm.
and maybe planets like Neptune and Uranus. But those very tiny rocky bodies are just too faint, really, and too close to the parent star in general if they're going to be in a habitable zone where life can be supported. So Habitable Worlds Observatory really is genuinely the next step, but the next step that is designed to address this particular question. The size of the telescope is being designed to go and really detect directly Earth-like planets orbiting other stars and image them and then take spectra so that you can do a diagnosis to characterize whatever atmosphere they might have or study the surface. Uh, and those are the main steps that will actually allow you to possibly answer that question. Um, the very simplistic way of looking at it is if you see a planet with an atmosphere that looks like the Earth, then it's pretty certain that there is something going on its surface to do with life. Um, but it is more difficult and complex than that because the Earth's atmosphere hasn't always looked like it does now. In deep history, when life was present on the Earth, the atmosphere of the Earth looked quite different. So the question is quite a complex one, and understanding, exactly whether you've got a real clear answer is a bit more challenging than just finding something that looks exactly like we've got. We may not do that, and then we'll have to try to understand what it is that we're really seeing.
Yeah, I find particularly interesting the point that, let's say, Hubble was designed like if we compare just to let's say to get closer to the common experience of everyone, Hubble is like the site in terms of sense of that a person may have, and the web added some other, I would say, senses to let's say to investigate the almost the properties of some matters that's out there, and as matter I mean planets and celestial bodies, and also the fact that well, you added sort of I would say dynamic of the systems in terms that let's, as you say, an atmosphere may look like something may look like to have some characteristics now, but maybe those weren't always like that in time.
Mhm. Well, the Hubble and Webb essentially attuned to different science questions. If you're going to build a big telescope and spend what ultimately is quite a large amount of money, Webb was more than $10 billion. Hubble was probably a similar price over time as well.
Okay.
So these are the most expensive facilities that we put into space. Um, there has to be some really critical, important science to drive those facilities. Hubble was very much focused on understanding the age and the size of the universe, for example. Now, it's done lots of other science because it's capable of doing a lot of other science,
Hmm.
but there were one or two really critical things that it had to do, which it did. And similarly with James Webb. James Webb is an infrared telescope because after Hubble, the next really big science that people were excited about was about how galaxies were formed in the very early universe. So you needed to observe in the infrared to find those really faint galaxies. And that then determined the size of Webb that was required and the instrumentation that's used and the wavelength range. Uh, Habitable Observatory, it is taking the same kind of approach. So the key, high level science goal is this search for life and Earth-like planets. But it's an observatory. There'll be lots of other science that the instrumentation will be capable of doing. But
Yeah.
it's that search for life that is the main thing that drives the design of the telescope in terms of how big does it need to be. Uh, if you want to observe very faint planets near stars, you've got to somehow block out the light of the star. So that you need a coronagraph that's absolutely, extremely efficient. Now, Webb has a coronagraph.
Hmm.
Sorry, the Roman Space Telescope has a coronagraph, which is Roman is a bit of intermediate stage between Webb and Hubble Observatory. Uh, and that is being put on the Roman Space Telescope to prove the technology and to push towards having that instrument ready for Habitable Worlds Observatory.
Yeah, so in this perspective is at least limited to what you were saying. It's a sort of a test bed for the coronagraph. And
Yeah,
okay, okay, and yeah. Also, I read I read an article that you provided me last couple of weeks, and I'm referring to the article titled "Who's Next," and which was published August this year on academic.oup.com/astrogeo. And I was very fascinated by also the details in it. And also the articles notes that HWO emerged from the studies like LUVOIR and HabEx. So as we were saying that maybe we use some spacecraft, some telescope as a test bed for something else. Also, in this case, what are the lessons that you took from these two studies?
yeah. So those studies were set up very specifically by NASA to feed into Habitable Worlds Observatory as an idea. Um, in the US, every 10 years, there's essentially a survey of astrophysics that
Okay.
asks the questions of what is it we want to do next. Both Hubble and Webb were things that came out of those studies. It's big committees, lots of input from the science community, and the survey publishes a report that recommends what facilities, not just space, but also ground-based facilities, need to be built to progress science. Now, at the same time, there was a lot of concern about cost overruns on Webb, and delays to the Webb program, and the reasons for that are quite complex. But the basic reason that everybody seemed to agree on is that it was because at the time that they decided to build the Webb Space Telescope, not all the technology and not all the definition of the science had been completed. So the LUVOIR and HabEx studies were actually, NASA was instructed by the survey that they must do these studies to essentially reduce the risk of cost overruns and delays, to feed towards a more mature decision process. So actually NASA did 4 studies. There was these two, HabEx and LUVOIR, which were basically focusing around UV, optical, and extrasolar planets. They also studied far infrared observatory and X-ray observatory as well, to the same level. And those 4 studies were actually fed straight into the Decadal Survey to help the decision-making process. And the conclusion of that survey that was published, I guess now, well, it would be 2021 was when the report was published, were that they should be a large UV optical telescope. And it should probably be about somewhere in between the kind of scale that had been envisaged for HabEx and LUVOIR. So both these studies fed straight into a decision that there should be something that we now call Habitable Worlds Observatory. And also a lot of the technical work done around the science cases and identification of technologies slots straight in to what we're doing with Habitable Worlds Observatory. So the 2 communities that supported those, and I worked on LUVOIR, are now all joined together as part of Habitable Worlds Observatory. So it's a lot of effort. Those studies ran for about 4 or 5 years. So there was a lot of work and big reports coming out of it that provided substantial input into where we're going with the design of Habitable Worlds Observatory now.
Yeah, but this is very interesting because usually, like, let's say, in a more I would say business, but even though it's not the, let's say, the perfect word to describe this, but usually the risking activities are made for every product that maybe I would say more in a company perspective is designed, is made, is built, because you need data to, let's say, to drive the whole process of building something. And it's interesting because from this we can see how also in science this is done. So you base let's say your opinion, your let's say your drivers to data and to studies that you also gather along the path until, let's say, the final object. And this is really interesting. And I think it's also the point of contact with a more, let's say, company perspective approach. This was all for today. The second of 3 episodes talking together with Professor Martin Barstow from the Space Park Leicester and talking about HWO, Habitable World Observatories. So we're talking about the great questions like, are we alone in the universe, and some others. So thank you for being here. Don't forget to subscribe to the SpaceInfo YouTube channel and to be notified when the 3rd and the last episode of this mini series will be published. So thanks for watching. See you next time.